Good morning and welcome to CPSE's sponsored webinar, Technology Adoption to Support International Accreditation with Esri. Presenting today are Mike Cox, Esri's Director of Fire and EMS Solutions, and Lieutenant Steve Rivero, Orland Fire Protection District's GIS Manager. Mike retired from Henrico County Fire Department in Virginia after 27 years. He served as Deputy Chief responsible for operations, emergency management, planning, accreditation, budget, and human resources. At Esri, his responsibilities include advocating how fire and EMS agencies leverage geospatial information and technology to achieve their response and recovery goals. Steve has more than 25 years with Orland Fire Protection and has been using his expertise in public safety geographic information systems by providing their leadership the necessary resources to make proactive, intelligent, and data-driven decisions. Steve is the exclusive provider of GIS services to the Illinois Fire Chiefs Association and the Associated Firefighters of Illinois. At the end of the webinar, please contact Esri directly for additional information and be sure to visit their booth at the 2020 Excellence Conference, March 3rd through 6th at the Caribe Royale Hotel and Convention Center in Orlando, Florida. Mike will now begin the webinar.
Thank you, Cindy, and hello, everyone. I am Mike Cox, your Director of Fire and EMS Solutions. Essentially, I'm your GIS liaison officer for any of your fire, EMS, rescue, GIS needs. And lucky enough to have with me today Steve Rivera, Lieutenant from Orland Fire Protection District. Steve, you want to say hi?
Yeah, hi, everybody.
So Steve's done some amazing work for his department and several others related to using GIS for planning and accreditation. So he's going to give us, an overview of some of the projects he's completed up in Orland Fire Protection District. So, public safety agencies face challenges and threats that are more and more complex and unpredictable every day. I mean, social unrest, public health issues, severe weather. It's not just fighting fire, day to day. It's the emerging threats that really take us by surprise. And we can use GIS to build efficiencies into our response and deal with some of these emerging threats. We can't just continue to build fire stations and hire firefighters to throw at these problems. I mean, we've got to be able to be fiscally responsible in how we approach these issues and deploy our resources in an efficient manner, in the most effective way possible. The health of a community depends on the effective operation of public safety agencies, and GIS can improve that effectiveness. And so, what is GIS? And GIS, it's not just a map, right? It's the ability to gather data, analyze it, understand it, make good decisions, and then communicate that incident intelligence or that data with others, so we can collaborate and coordinate our response or coordinate our activities. So it's much more than just the map. It's the ability to use multiple application types, whether it's field applications, dashboards, story maps, web applications, and to be able to distribute this data and this intelligence to all of our key stakeholders. So whether it's boots on the ground, command post, planning section, could be our elected officials, certainly the public we communicate with on a regular basis. And it gives us the ability to interweave any kind of data that you need or you can get a hold of to provide that visual product to help folks make decisions or understand what's happening in their environment or what's going on in the community around them. And when we talk about accreditation, the accreditation process, one of the first steps is to do a community risk assessment. So we can use GIS to do that assessment very, very effectively. You can acquire data that identifies risk, and that can come from multiple sources, whether it's your records management system, your CAD system, or some of your demographic data that you can develop a community profile, identify causal factors, and identify who's at risk in your community, and then what is causing that risk. What are the threats? And this comprehensive risk assessment can be very effective when you include local data. So we talk about doing a risk assessment, and some localities will do a risk assessment by first due district, or they may do a square mile. You decide what your planning districts are, planning zones are. But why not do a risk assessment based on every address point? Why not look at each individual structure and how it's being impacted, not just by fire, but by natural disasters or man-made threats, and have that information available with demographic data, so you can understand where are my highest risks structures, where's my highest risk to the community, what's the highest risk to the firefighters, what's the highest risk to the occupants, and then understand, what does that community look like. So that map on the right you see there, that's our tapestry segmentation that we provide, and it gives you a good idea of what's happening at the neighborhood level. So you can look at, this is actually San Diego's first due districts overlaid over the tapestry segmentation. So you think about being a station captain or battalion chief, the ability to look at a first due and understand very specific behaviors and demographics that are involved in that first due district. So, median age, household income, how do they travel, do they commute, what's the daily population versus nighttime population, things of that nature. And then take that risk assessment and, as part of the accreditation process, be able to operationalize that. So to be able to take a risk assessment and put it in your CAD system and be able to dispatch based on the actual hazards of an individual address. So we're not just dispatching to single family dwellings, right? We're not sending the same resources to 800 square foot bungalow that we're sending to a 5,000 square foot mansion. And we're not sending the same manpower to a convenience store that we're sending to a big box store, right? The job task analysis obviously doesn't indicate that works. So to be able to have on dispatch the data that comes from your parcel layer data and have the exact characteristics of that structure, what are the threats, and what is the needed manpower resources to send for that fire or for whatever the event may be. And we do that through a risk assessment of identifying target hazards. And Steve's going to speak to that quite a bit, but this is one of our off-the-shelf solutions that you can get from our solutions page, which will send out the link to that shortly. But it allows you to do a very simple workflow and basically give a hazard rating on every structure in your locality. So it doesn't take companies out in the field doing inspections, just having the data from your parcel layer and be able to run this workflow in minutes and understand exactly what every address point characteristics are and what the threat is, again, to the firefighters or to the occupants. And so with that, I'll turn it over to Steve, and he can tell us about how he develops his community profile.
Thank you, Mike. So as we get into this, this was done for the fire department that I work for full-time, still career firefighter there, Orland Fire Protection District, which is located in the suburbs of Chicago. As of right now, we're Illinois' biggest fire protection district. And one of the accomplishments of one of our officers and our battalion chiefs were to go through and accomplish accreditation. Now, when I started with Orland a couple decades ago, the fire chief at the time he actually started the process of accreditation, but it takes a lot of personnel, a lot of analytics, a lot of data to accomplish this. So it kind of went dormant. And then recently, in the last couple of years, it was brought back to the surface, and our battalion chief and our accreditation manager decided, hey, it's time, let's do this. Once you start the process and you say we're going to do this, you got about an 18-month window that you say we're starting the clock. You got an 18-month window. At the time that we started it, I was actually injured, came back to work 2 months into it, but we had other GIS firefighters that helped out in the GIS department start helping the accreditation manager. Once GIS got involved in it, we were able to finish the project within 6 months. And that has to do with the tools that are available to do the project. And Mike touched on some of those tools in the beginning of the presentation. But those tools are doing two major functions in a project like this. You're collecting data. So some of the data that we're going to look at is just data that needs to be seen or visualized. But the big burden or the heavy lifting that these tools provide is the analytics. You're able to analyze mountains of data and incidents and join them with other data sets and create risk hazard analysis and analyze your performance. And that's the power of GIS, is it allows you to do all this work in a condensed time because it is so effective and efficient. And one of the byproducts of this is, even though being from the fire service, when it comes to standards and stuff outside of the fire academy, we usually don't talk and touch on some of this stuff after that. So going through this, we also use this to help keep our firemen educated and what terminology is, and to bring things to light that we kind of know, but we don't really visualize before. So when we were using GIS, one of the first things that we have to get into is we have to, for community risk analysis and performance measures, we have to start to understand our community profile. And so whether you're going to do a complete accreditation, these next couple sections are the foundation of what's called a standards of cover. And you need to accomplish that standards of cover in order to move to the next step, where it's a foundational block when it comes to accreditation. So one of the first things that we have to do is we have to understand our boundaries, or our service area boundaries, and this is just the legal description. So most agencies have an idea of their boundaries or know their boundaries. It's defined somewhere. They even have a map. What is interesting is that how many agencies don't have a digital version of this. It's not on their website, whether they're just using a Google map with a pin of a station, but there's no digital. It's just missing. So this is usually a piece that most agencies, it's just nice to have. And then the verification of the visual aspect of that between agencies. No, we cover that. No, that you guys cover that. No, you cover that. And so this is the start, the foundation of that, of the community profiles. Just knowing where your legal boundaries are. What are you responsible for? What's the total response area, or your total responsibility area? And then we get into what's called your area of responsibilities. And this is within your total response area. This is within that boundary. We need to look at the different types of areas of responsibilities. And most firefighters in the service know this as still districts, or first due areas. And they're usually really nice, neat, drawn lines. They follow this road or that road, then they go down this court or through this along this creek and stuff like that. And so this is kind of what we see in our heads if we don't actually see this on paper or in digital format, but this is what we see. So this is our still districts. But when we're talking about areas of responsibility, we actually have to visualize it a little bit further than that. So for example, our community, our department and the neighboring departments, we're dynamically dispatched, meaning that the incident comes up, the CAD will figure out what appropriate resources can get there faster and then send that. Doesn't matter if you're out of that station or not, they're going to send the first appropriate or closest resources. So if, excuse me, so if everybody is in the station, this is not how our CAD sees it. This is not how we get dispatched, even though we would tell you this is what it is. Our CAD sees it like this. And so this is actually our area responsibility. So this is really our still districts. And so this is one of the first maps that we had to change when we went to dynamic dispatch, because the firefighters were struggling with, no, that's ours, that's yours, that wasn't mine before, why is it now? And so just defining whether you're dynamically dispatched or you're statically dispatched, just to define that as part of this area of responsibility, as well as you have different resources. So for example, we have 2 trucks in our community. And so when we're looking at area responsibilities for our trucks, this is what that looks like. So these are our truck response zones. And then you could continue on and do this for, if you provide EMS, we provide EMS, we provide 5 ambulances out of 6 stations. And then we also have to go outside of our jurisdictions and say, okay, and then this is where we respond to auto aids and mutual aids, as well as these are the areas that are being covered inside of our total response area by those exterior communities. So really breaking down that area of responsibility into the different categories is usually a new experience for an agency to get it out in the visual format. We kind of know it in our heads, but we got to get it out in the visual format, because it's this foundation of knowing these areas that start to play into the performance and where we'll be able to provide those resources, or if we need to move resources, what does that look like? And as we move forward with accreditation, that we have to break it down a little bit more, and we have to get into what's called planning zones. We cover about roughly 32 square miles. We can't just organize this into one area that we're going to just look at the whole thing. So it's got to be broken down into logical and bite-sized chunks. And this can be broken down into geographical areas such as 1 square mile or a kilometer, or I've actually worked with a couple agencies where they decided to use the national grid system. If you ever have a big disaster and you have federal assistance coming in, they're going to go to the national grid system. So we thought it's just a good idea to, already instead of having page numbers, they use a 4-digit national grid number. And so that way their first responders are already accustomed to it. You could also break down the planning zones by use type. So for example, we have a mall, we have a couple malls, and so we could say this is the mall planning zone, or this is the industrial park planning zone, or this is the airport planning zone. So it could be done geographically size or by use types. And then as we move forward and we start to get into the community profile, now that we have these areas, we have to start looking at the demographics for the population. Anytime you analyze the data and you want to see if the data that we have, incidents, the emergency incidents, are have any statistical value, it always comes back at the fact that our incidents, our emergency incidents, would be random, is 0.0001% chance. That means that it's 99.999% driven by patterns, and those patterns are based off of people. Very few of our incidents are nature or weather or what they'd consider acts of God. The great majority of it are from people. So it's nice to know the population and the breakdown. And when we examine the population, we also have to examine the population not only by, so this is done right here by our area of responsibility, but by each of the planning zones. And we need to look at the different types of population in there, not just the numbers, but look at the risk factors, such as young children under the age of 5, or elderly over the age of 65, or at a higher risk, daytime population versus nighttime population. And the good thing about all this population information, as Mike had showed in our earlier presentation, earlier slide, that is available at the through the Living Atlas and through the a lot of this predefined layers in the Esri platform. They have a whole tapestry where you can get the demographic information, you get total population, median income, at-risk population. And so if you're missing any of that or you don't need it, you know, these are great resources to get this information. Also with the Living Atlas that's provided by Esri, we're also able to get a lot of the other layers that are needed to start analyzing as well as building the community profile, such as if you're missing your transportation layers, land use layers, topography or climate. You know, these all are layers that have some sort of impact on your risk. Now, they're not going to be the same for every agency, and they're going to be, you know, our agency, we're not really worried about wildland fires. We really don't have wildland fires. We're not really worried about high-rise emergency incidents. We have a couple tall buildings, nothing taller than 6 stories. And you go to the city of Chicago, which we're just outside of, that's a different game. If we go out even a little bit further west into the agriculture areas of Illinois or down south where I started, we don't have wildland fires, we have crop fires. And so it's a different hazard out there. But in the Living Atlas, we can get a lot of data that we might not have in our data set. And the good thing about the Living Atlas is not only does it have the data in there, but using ArcGIS Online or ArcPro, we're actually able to go ahead and export only the data that we need. So we don't need the full set. I don't need every different type of population breakdown. I just need total population, day, night, and at risks. And so that's the nice thing about having all this information, but also equally as important is being able to filter the information so that it's not a complete overload. So after we build this community profile and get the everything from our own agencies, boundaries, response areas, and the population characteristics and stuff like that, we start going into the community risk assessment. We're able to start looking at what risks are actually out there. And so we take what we just did in the previous section, and we take everything that has to do with the population, that has to do with the location of the population, and in this area, then we add the hazards, the risk hazards, and as well as the service demands. Now, those service demands are the emergency incidents, or our agency and a lot of agencies out there are responding to non-emergency incidents. They're just service calls. And we add it to the previous section, and now we're able to start getting a real look at the risk that the community, of our community. And we haven't even got into performance analysis. We're just looking at the community risk right now. And we start that is by looking at our response data. And we take that response data, and as Mike said, it comes in, it can come in many different forms. If you have an on-premise database such as your RMS system, or if you're lucky enough to have your CAD and be able to hook to your CAD, you might use just do a database connection. Or most agencies, including the agency, including my department, a lot of times we just export the data set that we need, and we could put it in a CSV file or an Excel. And then from there, again, the software works really well at bring that in and putting it into a GIS table, as well as if I have the address points and the lat and longitude, I'm able to then go ahead and geo-reference it, which is, was one of the things that we need to do, and get those points on the map. Because once we have that data, then we need to start classifying it. We need to start breaking it down and saying, okay, what is this? And all right, this is an EMS call, or this is a service call, or this is a fire. Even in the fires, is this a structure fire? Is this a rubbish fire? Is it a vehicle fire, motor home fire? And so we need to start not only classifying the risks that we're responding to and the non-emergent calls that we're responding to, but we also have to start looking at where those incidents are happening. And so we really need this historical data to do that. And when we're talking about the accreditation, we need to look at a minimum of 3 years to get a good pool to analyze against. 5 years after that first accreditation cycle is going to be the requirement. So anytime that I do it, I always ask minimum 3. If I can get 5, that's great. And then there's a few agencies that are like, here's 20 years of data. Well, again, that's good, unless you want a history lesson on how your risk has changed. We really can only use that last 3 to 5 years because things do change over time. And so as we move forward, we need to take these classifications and we need to start analyzing those the breakdowns of the classifications. And again, those classifications are going to be dependent on your agency. If you're an agency that doesn't run EMS, then you're not going to have an EMS classification. If you're an agency that doesn't do transports, but are first responders to a private ambulance, well, then you're going to have to do an EMS classification. And so again, we need to look at the type of incidents as well as the location of incidents. And again, whether it's ArcPro, Map Online, ArcMap or Arc Desktop, or AGOL Online, you can do all these tools. Oh, get a little feedback there. You can do all these tools and to produce hotspots and to see where these incidents are. While that's great in the software, we need to be able to bring it out and put it in reports. And I have found it very easy to do that, to be able to export the images. ArcPro actually puts them into, you create layouts now. You could do that in the ArcMap as well, but create layouts and to export it so they go in documents. And the story maps and the online web apps and stuff are great to see, but there's still a need to have paper documents, so that that they can have it at the front desk and somebody could come in and pick up that document. Or sometimes the accreditation reports do make a great non-habit forming sleep aid if you're having a hard time falling asleep after returning from a call. So we do need to print those every once in a while. And so we break down these classifications of fires, and then we also have to look at, like I said, the other type of classification. So we have, we do EMS, and again, this is just looking at that 3-year data source for EMS and showing the hotspots of where that's happening, broken down by each of the station, the percentages of the overall incidents of EMS incidents. Now, this is kind of what our accreditation manager saw. He saw a map. He saw some numbers. Okay, out of the study period, 17,862 incidents. Here's the percentages. That's what he saw. That's what the public sees. But what wasn't seen, and fortunately, the accreditation manager did get the headache from it, is that we actually had, in our study period, we actually had 4 different RMS databases. We had changed from one software to another, both on premise, and then our new software, we went to the cloud. So they weren't going to take our data from on premise and put it into the cloud. We just had 2 of them, and then we brought it back down to on premise, and same thing. Then we're going to take the cloud information, bring it down to the premise. But you know what? The different software version, so we couldn't take our old on-premise data and move it into the new one. So we had 4 different databases that had our RMS, or our record management, had our incident data in it. And it was very frustrating for him to try to get this information all put together from these different data sources. But as Mike had pointed out in one of the previous slides, one of the strengths of using the Esri platform is its ability to connect to these different data sets. So not only are we able to connect to Esri's maintained data sets, demographics and stuff like that, or the national data sets such as Tiger or some of the other .gov data sets, but we're also able to establish connections to these different data sets. So our 3 on-premise databases we just made connections to, and then did a export from the cloud RMS and just brought them all into GIS, one database, and from that we're able to analyze everything against. So it really made it a lot easier for our accreditation manager to move forward, knowing that from that point on, you only had to look at one data set, and that was it. But behind the scenes, we're actually pulling from 4 different data sets. So after we started classifying these EMS and fire, then again, you need to go down and do the same thing for all the other risk categories within your community. And the CPSE, there's many different manuals out there. The Community Risk Assessment Standards of Cover manual goes, as well as accreditation manual, goes through and gives you all the different possible different types of risk classifications that you might want to analyze against. And so we take these historic demands, we analyze it, and not only do we need to figure out, okay, where these incidents are happening, at what volume are they happening, but we also have to look at the consequences of these incidents to the public, to the individual that is having the emergency, as well as to the resource that's providing the emergency. And so once you start to go down this process, you realize the importance of keeping good records, because just because we respond to an incident and we mitigate it doesn't mean that it was a good outcome. Just means it was mitigated. And so we need to know those outcomes. And so we start to analyze again, not only where and when and to what degree are the incidents, but also did we have a positive outcome? How many times did we have a positive outcome? When we have had a negative consequence, what was that negative consequence? Was it just isolated to the individual having the emergency, or was it or did it not only impact the individual, but it also impacted the agency or our department in a negative way? And so we need to start looking at those consequences and those outcomes from those incidents. And so to be able to collect all this, to visualize it, to analyze it, and then to compile it and to put it together, we really need to have tools to be able to do this. And this platform has allowed us to do this without switching back and forth to different softwares. And it really provides all the heavy lifting that used to take 18 months to do, going over Excel sheets.
And developing that standard of cover, you know, and Steve talked about, you know, response zones and planning zones and areas of responsibility, but certainly understanding, you know, in a dynamic assessment, what is really your first due area, what is really your coverage, and where are the gaps in our coverage. So you can do drive time analysis now very simply in 3 or 4 steps in a web browser. And you can use real-time traffic data or historical traffic data. So if you want to see, you know, what's my 4-minute travel time at 6 o'clock on a Wednesday afternoon during rush hour, or what's my travel time at 2 a.m. on a Sunday, you can do that very simply by bringing in live traffic data. So it's a very effective way to assess, you know, what's our coverage and then where are our gaps. And you can see the top right there, that was one that was actually used during a bond referendum to justify a fire station. And what that shows is that heat map there, that red zone, is where the department was not meeting their response time goals. So that 9 minutes, 90% of the time, 90th percentile, was not being met. And the blue outline is the 4-minute travel time. So it shows that from a proposed station, the dot in the middle there, that proposed station would cover or would impact that gap in service that you see there by that map. But that's not something you can argue with, right? That's not a gut feeling. That's not because I feel like we should put a station there. That's actual verified data that provides the true story in a visual format that's easy to understand, and the ability to do that assessment with CAD data. So you can see there another 4-minute drive time from a proposed station location, and using historical CAD data, you can actually see or estimate how many calls would be run in that first due district, or how many calls would we run in the previous year if that station had been there. So it's very simple to do that. This was done in Insights, which we'll show you a demonstration of that towards the end of the webinar today. But in addition to that, you know, Steve talked about using demographic data to enrich the visual product there to understand exactly what's happening. And on the right, you can see in that Insights, being able to pull in the data that Steve was describing. You know, what's the total population in that first due area? What's the median household income? And where's our at-risk population? You know, what the very old, the very young. How many households in this first due maybe don't have a vehicle? You know, you talk about doing an evacuation zone or having a flood zone where you can identify how many folks don't have a vehicle to do a self-evacuation. So vital information to have when you're doing that standard cover and self-assessment.
So when we get done doing those assessments and we collect those data, then we need to start getting into, well, that's good, we know all this, but we focused on the community. We focused on our boundaries, and we know the risk, we know where it is, we know the outcomes of that, but then comes the big undertaking, or then comes the important part. How are we doing as an agency? How's our performance? Are we providing what we need to do, what the public thinks we should do? Are we being effective and efficient? So we need to look at our overall response. We need to look at, are we being consistent with our response? Are we reliable? As well as how resilient are we? If we have 1 or 2 calls, are we wiped out? Or are we able to handle a very big call, a mass casualty, to what size, or maybe a couple structure fire plus a couple incidents, and are we able to bounce back quickly from that so our agency is not taxed for a while? And then again, the outcomes of all those incidents, not only for the agency, but for the individuals that we are there to serve. And so we need to measure all that. We need to see where our performance is. And of course, one of the agencies that does that is ISO. That one of the agencies that goes ahead and measures that. But the good thing about the accreditation process is it meets NFPA, it meets ISO, it meets a lot of the other national standards that are set for the agency. And so by going through accreditation, it's like the big, it literally is the big gold star. It's the big kahuna, you could say, that we're trying to accomplish. And so as we start to go and analyze our performance, we need to be able to do stuff and say, when we're analyzing, most agencies don't know this. They don't know where they are right now. They don't know their benchmarks. We know that, you know, I think we're at about 80% of being able to get to our calls within less than a 4-minute travel time. But they really don't know because there's no measures out there. So we need to measure against the national standards first, see how we're doing there. But once we go through this process, then we know where we are as an agency. And then from that, you have us, okay, these are the areas that we want to improve, and we could start to monitor it. So we're looking at our drive times here. And again, we're just using this to say, okay, this is about where we can cover how far we can travel. So any incidents within that 4-minute travel time, we should be able to get there 100% of the time because it's within 4 minutes of our travel time. And then, so we take our streets networks and then we do a drive time analysis. We say this is what our coverage looks like. And we analyze not only the structures and the networks in which we move, but we go ahead and we analyze again our performance. How many times? What's the percentage that we're hitting the? We're getting there within 4 minutes travel time, or 5 minutes and 20 seconds of response time for fires, or 5 minutes of response time for EMS, or how about 8 minutes of travel time for a full complement? So on a structure fire, 16 personnel per NFPA within 8 minutes, within 9 minutes and 20 seconds. So I should have 16 personnel on the scene. Are we meeting that? What's our 90th percentile times, 80th, 70th, 60th, and 50th? And that way we can see if we're doing really good up until about the 80th, or maybe we're doing really bad from the 50th on up. So it's nice to have that broken down into those periods, as well as how many times those incidents are being answered by the primary station versus a secondary station. How many times the primary station is unable to answer any call or their own calls. You know, what's going on there? So we start to analyze all these different aspects of our own performance. We take our performance measures and our performance analytics, and we then go ahead and we tie it up with the community risk. And when we put those two things together, we start to get a good picture of what's really the impact, not only of the incidents, but providing the service to those incidents, the impact to the public as well as the impact to us. So one of the tools that Esri had provide is the target hazard identification template, or the target hazard template that Mike had talked about earlier. And very simple, out of the box application. And when it first came out, I used it. It was designed for. It would do it for parcels. So you'd be able to do it for parcels, which is fine, which is good. But when, as a fireman, when we look at the parcels, I might have a parcel, but on that parcel, that's the strip mall parcel, or that's the plaza parcel. And on that one parcel, I might have 3 buildings. And in one of the buildings, I actually have 6 occupants. And so one of those occupants might be a nail salon, the other one might be, you know, the paint store, and then the other buildings, you know, it's a shoe store or a dress shop. And so each of those buildings on that one parcel has a different risk category, a different hazard. And when we're talking about identifying target hazards or identifying hazards in this application, it's more of a hazard of having an emergency incident there. So we're looking at what would it take to mitigate that? What's the hazard as far as it's going to be on the provider of the service, so on the firefighters? Is it a high risk? Is it a low risk? And so some of the things that it takes into account are things such as occupancy type. How tall is the building? The area of the building. We calculated fire flow. as far as life safety. So are people ambulatory or are they not ambulatory? The nursing home, third floor, are not going to be as ambulatory. Assessed value. So how much is the building or the property worth? What happens if what happens if a multifamily gets destroyed versus a retail store? That's going to have a different economical impact. And then you take these different categories and it combines the score, and then you have a total risk or total hazard score for these individual buildings. And so this is one of the this is the application that I did for an agency that so that they can see the risk level, and these are the categories on which the risk is based. Now, the good thing about this is you can add in your own categories. You can make adjustments if you want to. So if we have in here, we want to know, we have a big metal truss or wood truss. And we want to know anytime there's truss in a building, whether it's the roof truss or whether it's floor truss, we want to know anytime there's truss, because we're going to give any building that has truss type or truss construction, we're going to go ahead and give that a risk score that's different than a building that doesn't, because we know that it collapses a lot sooner. And so we're able to make those adjustments and then go ahead and put it into a visual application here, where if, hey, we're going to start doing our pre-plans, we're going to reboot those things, we're going to get it going again, it's nice out, chief doesn't want you sitting in a lazy boy, let's get outside. We could actually use this application. Okay, where are we going to start first? Well, how about we start at our red buildings, because it's color coded. These are different risk categories, and it tells you why. And so again, this is built off of that template that Esri had put out, and then all I did was we just break it down. Instead of doing a parcel, did it to each individual building. Now, the best part about this is when the agency started looking at this and said, okay, that would be great. We can get our target hazards. We can get our, we can analyze the community. The problem is we don't have all this information. You know, we didn't inspect all these buildings, or we don't think our data set's good enough. It's okay. You don't have to go out to each building, from maybe the assessor's office to the county, to any fire inspections that were done, to other online or available data sets. This was all done from my office. So this was all done remotely. I'm calculating all this. So as far as the fire service goes, it doesn't have to be exact. If it gets close, that's good enough for now. It just gives us a starting point. We can always correct it down the road, because right now we have a lot more information than we had when we didn't have this. And this is the information that's important to us. Whether I know the fire hydrant is 10 feet or 50 feet, doesn't matter. I'll find the fire hydrant because I'll see it. But if I know it's on this side of the building, or if I know that this building, you know, this is the fire flow versus the other one, as long as it gets me going in the right direction. So this is just the example of how we used the template that was given by Esri, or that Esri has, and this was done on ArcMap, you know, several years ago, and I think you guys are about to roll out a different version for Arc Pro. So I'm looking forward to that myself.
That is correct. Yes, we are, Steve. We're getting ready to update the target hazard analysis and several of our solutions on their on our solutions page. So certainly, if you take a look at that, you can see some right off the shelf. You know, you can download today and add your data and start using it to get things done. Whether it's the target hazard analysis, or it could be, you know, doing pre-plans, actually field mobile applications to collect data for your pre-plans. I wanted to show just a couple of apps real quick. This is the Insights application we discussed earlier. And this is an analysis of some sample data, so it doesn't really indicate the actual performance of a given department. But this is, you know, several thousand calls from an RMS system. And what's nice about this is, you know, you can load the data from an RMS system or from a dispatch CAD system and start doing this analysis pretty quickly. And Insights, it's a web-based, it's not a desktop application, and it's all drag and drop. There's no coding. You know, it's pretty simple. Actually, as you build out one of these analysis, you actually have it records every click, so you can see where I added my data, and then I started filtering data and calculations. So then if you ever want to add additional data or actually send this model to another department or another agency that needs to do the same kind of analysis, you can do so very easily. But you can look here, and it's pretty effective in telling us a lot about what's going on in this city. So we can look at calls by district. So this is not by unit, this is by district. And Steve had mentioned, who's running into who's first due, right? Who's covering calls in a given first due district. We can see here, 17 is pretty busy, that district, but we can also see that they're getting backed up by 18 and 14 on a pretty regular basis. So hundreds and hundreds of times annually. Or if you just want to look at a certain call type, if we just want to look at medical calls, we can do so. And obviously all the analysis change as you do that. And it provides a map-centric kind of view as well. So you get that geo context of being able to see where things are happening. So you can see the heat map updating there. And again, easily doing analysis like time of day, day of the week. So when are we running most of our EMS calls? And again, if you just want to look at certain units, we can do that as well. So we just look at one unit and you can see, what kind of calls they're running, time of day they're running, and then what areas are they running into. So not just their district, but how often are they running into somebody else's district for a given call type. So it's an excellent way to show, what our coverage is. And then breaking it out by, our performance metrics, right? How are we doing performance-wise? The turnout time is a big one for us, and who's got turnout time issues. I like showing this because obviously we've got some bad data. So by visualizing your data like this, you can easily incorrect or that bad data. Another I'll show you in a second with the unit hour utilization. But understanding turnout time, what's our travel time, and then what's our total response time, and the ability to see 90th percentile, not just by unit, individual unit, but by district as well. So what's our 90th percentile in a given area? So not just we can just look at at engine 23 if we wanted to, and see where they're running and what's the 90th percentile for call type or for location. But if we don't want to look at a unit, we want to look at a certain area of the city or the county, we can do that as well. So that's a first due area, and then that provides us what's our 90th percentile and who's running into that district and what kind of call types are in that district. So pretty effective way to analyze the data there. And then unit hour utilization. This one, I love this one. This is how busy are we, right? And here's another one where we obviously have some bad data, because you can have more than 100% commitment time in a given 24-hour period. So obviously that's incorrect data. So a good way to filter that out. So we did another analysis removing that bad data, and we can see who's the busiest. And these are just the engine companies for a given fire department. Who's the busiest by district? So where are we the busiest? And again, that shows you who's running in that district. It shows you call types and how long they're committed to individual calls. And you can filter this data any way you wish. So you can view this data however you deem appropriate. So what's most important to you? So we not only look at the individual units, who's busy and where are they busy, but the individual districts. I think that's pretty effective to be able to show an elected official or city county manager where are our busiest areas and what is our time commitment in a given area for a day. And again, we're map centric. We can see where we're busy. We can see time of day, so that temporal aspect to it as well. So very effective. And then any of these analysis you do, you can share out as a layer and consume it into any other visual product. So a basic map, web app, or a dashboard. So this is basically that analysis put into a single view. So think about having this in a fire station or having this in a battalion chief's office, where they can easily look at individual issues or citywide. So we can look at total response time, and I can look at one engine and see how they're doing, and it obviously takes me to where they're running, but it'll filter all that information as well. And then same for unit hour utilization. I can pick out an individual unit or look at an individual district and see what kind of calls we're running in there, and pull a call type by that. So any of these analysis you do in Insights, you can basically export as a layer and then consume it into any of your other visual products. So a very effective way to tell that story and to push it out into a fire district or to an elected official or something of that nature. So with that, I want to make sure we've got some questions in the window. We will get to those questions if by email, if nothing else. So the one thing I wanted to make sure everybody got was our email addresses. So there's Steve's there. So please, write this down, s.rivera@orlandfire.org. And certainly if you have any questions for Esri or for me, it's Mike_Cox esri.com. So please make sure you make a note of that. And again, send us any questions that you may have to the email as well. And because we're wrapping up here shortly. So Steve, I'll give you the final word before we sign off.
All right, thanks, Mike. It's first of all, I've worked with Mike for the last several years, and it's always been a pleasure. But the thing that opened up my eyes the most in this process is the ability to go through all that data, to filter it, to not only collect it and analyze it, but then to visualize it, to show it, to share it. We use story maps to share what the reports have to say in layman terms, so they could put on websites. It has really changed how we do things at my own agency, as well as how the other departments that we work with, how they're moving forward. Because Mike, you actually said it earlier, it's not about just knowing it. And the time of, well, you're the fire chief, or you're the expert, we're going to take your word, those times have long gone, because I could Google anything you say, and I need you to back it up with data. And this allows us to do that in a very effective and efficient way. So thank you, everybody. Thanks again for letting me be part of this, Mike.
No, thanks, Steve. Truly enjoyed your presentation. Very useful information. Got a couple of quick questions, and I'll cover this first one. It's our understanding that drive time maps use non-emergent travel. So in other words, they're using regular posted speed limits or whatever the speed value is provided in that street layer. And that's true. That's how you do it. Now you can pull in real-time traffic data, so it does actually provide you that, again, non-emergency, no red lights, no sirens, travel time. But we do have partners that use actual historical CAD data. So they'll pull response times in a given area and provide that estimated travel time based on actual response. That also gives you a good impact on, driving a ladder truck's gonna be different than driving a battalion car, right? So you need to know the difference between those, or could dig that deep, get that granular if you wish. And that's another one where if you have any additional questions about this drive time or travel time analysis, please, give me an email, shoot me an email, and I'll do my best to get the information to you. And then there's some questions about training. We certainly have training available on our website. Go to esri.com and go to training. There's online training that's free. There's also instructor-led training, and there's regional classes given on a regular basis. So that, I think, is about all of it. So Steve, one for you real quick. What was your data cleanup process like? So when you first started getting into the analysis for the accreditation process, what kind of data issues did you run into?
So the data issues that we run into are, the big ones are, especially when you do an export into like an Excel sheet, is to make sure that the field types as well as the field labels and stuff meet the schema, or the schema that Esri requires. And so actually, I learned how to do it from some Esri publications, some old Esri publications on fire service data and cleaning it up. So like just getting all your spaces, or having an underscore in your field columns, and we just do that in Excel real quick. And then after that, we just have a process where we bring it in and to make a table inside of a geo database, and then we go ahead and we then geocode all the addresses if they don't have latitude and longitude. You could also run the ArcGIS online geocoder. It does use credits though, but you could use that one to geocode and get your points. And after that, then it's just the analytics. And again, using Esri's tool set. So for example, they have the crime analysis tool set. It's the same tools, it's the exact same tools, just done for fire incidents instead of crimes. So it's just a little bit of cleanup, and it's just more to make sure that it matches the schema that's needed.
Excellent, thank you, Steve. So again, our email addresses are on the screen. Please make a note and send us an email if you have any questions. And come join us at the CPSE event in Orlando in the spring, in March. So that'll be a great show. So please come out and see us there. So thank you, and have a good day.
Thank you. You guys have a good day.
Thank you all. Bye-bye.